These are notes for section 6.1, day 3, exponent properties. A quick recap of what we've talked about so far, the two properties we've picked up. If you multiply by the same base, x to the third times x to the fifth, that would give you x to the eighth. When you multiply by the same base, we can add the exponents, 3 plus 5, to give us 8. The reason we can do this is because if we were to write this out in product form, I would have 3x's here, x times x times x, times 5x's here, 1, 2, 3, 4, 5. So x to the third times x to the fifth would give me x to the eighth. When you multiply by the same base, add the exponents. The other property we've picked up is when you have a power squared raised to another power fifth. X squared to the fifth. X squared to the fifth would give us x to the 10th. When we have a power to a power, we can multiply those exponents. And the reason we can do that is because if I were to write this out in product form, I would have 5 x squared. So x squared times x squared times x squared times x squared times x squared. I have 5, 1, 2, 3, 4, 5 x squared. And again, if I multiply by the same base, I can add the exponents. 2, 2, 2, 2, 2, 2, 2 would give me x to the 10th. So we actually take this second rule and just expand on it to get our third rule. And this is when we have a power of a product. Power of a product. So I have a power squared of a product, a bunch of stuff being multiplied. A product means we're multiplying. So I have x squared y to the third on my first example. X squared y to the third, which means I have 2 of these x squared y to the thirds. X squared y to the third, that's one of them, times x squared y to the third. That's 2 of them. I have 2 of the things in the parentheses. And if I go back to, if I multiply by the same base, the very first rule, I can add the exponents. Well, that would give me x to the fourth. 2 and 2 would give me 4. Y to the sixth. If I multiply by the same base, y and y, 3 plus 3 would give me 6. Again, I have 3 AB squareds. I have an AB squared times an AB squared times an AB squared. I have 3 of them because that's the exponent. So I have 1, 2, 3 A's, A to the third, and I have 2, 4, 6 B's, B to the sixth. So A to the third, B to the sixth. And on the last one here, I have 3x squared. So 3x squared times 3x squared times 3x squared. I have 3 of them. So I have 3 times 3 times 3, or 3 to the third, 3 times 3 times 3, x to the sixth, because I have 2 here, 2 x's here, and 2 x's here. Now you could simplify this because 3 to the third is 27. So either answer is acceptable, although this is one of the smaller ones that we could probably multiply that out. So our property that we want to pick up is how could I get from, and let me erase some of this to make it a little bit cleaner. How could I get from the problem to the answer applying the power product of a property? So how do I get from here to here without writing it out in product form? How do I get from here to here without writing it out in product form? And you can obviously see the notes below, or we could just take a look at the parenthesis. Well, I end up in my answer as x to the fourth. Well, 2 times 2 would give me 4. I end up in my answer y to the sixth. Well, 3 times 2 would give me 6. So the rule is that we can multiply each of the exponents on the inside by the exponent on the outside. And that should kind of make sense or ring a bell because it's exactly what we did up here in this problem. Only we had to do it just one time because I have a power raised to a power. Well, now I have a power raised to a bunch of powers. So I take this exponent on the outside, this 2, and I multiply each of the exponents on the inside. I take this 3 on the outside and I multiply it by each of the exponents on the inside. So I'm multiplying my exponents here, which is exactly like the second property we picked up. just more of it. So on number 40, I take this 5 on the outside, and I can multiply each of these powers on the inside. That's not 2 times 5, that's 2 to the first. So I multiply the first times 5, which will give me 2 to the fifth, a to the fifth, b to the fifth. I take this exponent on the outside, and I'm multiplying the exponents on the inside. 2 to the sixth, x to the 18th, y to the sixth. I take the exponent on the outside, and I multiply each of the powers on the inside. So again, to tie this into the second property we picked up, which is day 1 of the notes, is if we had a power like x to the 4th raised to another power 6, I would multiply these exponents, x to the 24th. Well, what I'm saying now is we do that just more than just one time. So let's say I had x to the 4th y squared to the 6th. It's essentially the same problem, except now I have to take this 6 on the outside and multiply it by each of the exponents on the inside, x to the 24th, y to the 12th. So it's the exact same property. I just have to multiply each of the powers on the inside, a to the 6th, b to the 3rd, c to the 12th. Down here on number 44, I could take this 4 on the outside and multiply each of these exponents. That's 3 to the 8th, x to the 12th. Now, we have to deal with this negative. The negative sign here belongs to the exponent of 4, which means I have 4 negatives. If I have 4 negatives, that makes my answer positive. I multiply my exponents, so that would be 2 to the 6th, x to the 12th, and now I have to figure out whether or not my answer is positive or negative. I have 3 negative signs because the negative belongs to the exponent of 3, which means my answer is negative 2 to the 6th. I have x to the 6th, multiply, y squared, multiply, z to the 10th, multiply. Now this negative does not belong to any exponent. It is on the outside of the parentheses. If it's on the outside of the parentheses, that makes my answer negative. I only have one negative sign. On number 47, again, I multiply my exponents. 3 to the 3rd, a to the 6th, b to the 3rd. I take this exponent on the outside. I multiply my exponents on the inside. I have 3 negative signs. I have 3 negative signs, which makes my answer negative 3 to the 3rd, a to the 6th, b to the 3rd. Now we can take each of these rules, the first 3 rules, and put them in the same problem and see what we can come up with. So we'll do the top 3 here on number 48. Should cut this video short. So what I have in my first term is 4x squared. And now I need to clean up this set of parentheses. So I multiply the exponents. That's 3 squared x to the 10th. Well, 3 squared is 9. 3 squared is 9. 3 times 3 is 9, x to the 10th. Now I can multiply these two together. So 4 times 9 would give me 36. 4 times 9 is 36. And when I multiply by the same base, I can add the exponents. 36 x to the 12th. On number 49, I have 3 to the 7th, x to the 49th, times x to the 3rd. 3 to the 7th, we'll just leave it as that. And when you multiply by the same base, you can add the exponents, x to the 52nd. And on number 50 here, again, I have 2 sets of parentheses. I need to multiply these out, simplify the sets of parentheses. So that would be 3 squared x to the 6th, power to a power we can multiply, times, I have 3 negative signs, so that's negative 2 to the 3rd, x to the 12th. Again, I'm multiplying my powers. 3 squared is 9. 2 to the 3rd, or negative 2 to the 3rd, would be negative 8. That's negative 2 times negative 2 times 2 times 2 times x to the 12th. 9 times 8. 9 times 8 would give us negative 72 x to the 14th. Hopefully that helps. See you on the next one.